So now that we've established how we draw these angles when we want to put them in standard position, and we've talked a bit about radians, today we're going to talk about two different things, coterminal angles, and then also converting between degrees and radians. Okay, so let's start with coterminal angles. So coterminal angles, all that is it's two angles that have the same terminal side. Okay, and the terminal side is like the side of the angle that's not on the x-axis. Okay, so the terminal side is the same, but they have a different number of rotations around the origin. Okay, so two angles that stop in the same place, but they get there by spinning around twice. Sort of like 8 a.m. and 8 p.m., right? Over the course of the day, those two times are at the same spot on the clock, but one of them you've had more rotations around the clock because it's later in the day. Okay, so that's what coterminal angles are. So let's take a look at an example. So let's start with a 45-degree angle. So a 45-degree angle, right? Here's my initial side of the angle. And then the terminal side would be this side right here. And I draw my little arrow to show that I've gone just a little bit of the way around the circle. Okay, so this is a 45-degree angle. An example of an angle that would be coterminal with a 45-degree angle would be a 405-degree angle. Okay, and it's a 405-degree angle because 405 is 45 plus 360. It's an extra rotation around the circle. So when I go to do this, here's my initial side. Well, my terminal side would be a full 360 degrees plus that extra 45. Excuse me, I sneezed. And the only difference is that when I draw this, when I do my arrow, I just make my arrow go an extra rotation around the x-axis, or around the origin, excuse me. So you can see that these two angles look the same. The terminal sides are in the same spot, but the difference is how many times you've spun around. Okay, and then another example would be a negative 315-degree angle. Okay, because a negative 315-degree angle, okay, well, that would start here, right? And negative 315 degrees, well, that's like 45 degrees minus a loop of the circle. 405 was 45 degrees plus a loop of the circle. This is 45 minus a loop of the circle. So when I go to do 315 degrees, I would go this way, because remember, our negative angles go clockwise, right? And it would end here. 45 degrees less than the full circle. And my arrow would go this way. So this is an example of three different coterminal angles. They all end in the same spot. They terminate in the same spot, okay? But they have different numbers of loops and directions of loops around the circle. Okay, so that's all that coterminal angles are. So when I ask you to be able to find a positive and negative coterminal angle from a given angle, it's pretty easy, and you've probably already kind of figured it out from here. Right? It's just a matter of how many loops around the circle did we do, okay? So if I have a negative 50-degree angle and I want to find a positive angle that is coterminal with that, all I'm going to do is I'm going to add a loop of the circle, just like we did here. So instead of just going to my negative 50 degrees, which would be somewhere down here, right? What I'm going to do is I'm going to say, okay, well, instead of going straight there, let me go this way instead to get there. So let me go a positive loop of the circle. So what I'm going to do is I'm just going to take negative 50 and I'll add a loop of the circle. And that's going to equal 310. So a 310-degree angle would end in the same spot that a negative 50-degree angle would. Okay, similarly, if I wanted a negative coterminal angle, I take my negative 50 and I'm just going to go a loop of the circle in the other direction. So I'm subtracting 360. So here I went a loop of the circle from negative 50. I went a loop of the circle in a positive direction. Now from negative 50, I'm going a loop of the circle in the negative direction. And that's going to work out to negative 410. So a positive angle and a negative angle that are coterminal with negative 50. All right, next one that we're looking at, 395 degrees. Okay, so 395 degrees. If I want a positive coterminal angle, right, I can add on a loop of the circle. All right, and then 395 plus 360, that is 755. So a 755 degree angle is kind of big, right? But there you go, that's coterminal. All right, now if I want my negative one, right, I want to go in the negative direction. So I'm going to subtract 360. And now here's the most common mistake that I see here. When you subtract this, this is 35 degrees. Is 35 a positive number or a negative number? It's a positive number. So what I have so far is I have two positive coterminal angles. I don't have a negative coterminal angle yet. The fact that you subtract a loop of the circle does not necessarily mean you're going to get a negative coterminal angle. Okay, so what I'm going to do from here is I'm going to say, okay, well, I know that 35 is coterminal, so I'm just going to take that 35 now and I'll subtract another 360. Okay, and that's going to get me to negative 325. And that is a negative coterminal angle. Okay, so just be careful of that because that's a really common mistake and it's a silly one to make. All right, so all of these angles, so 395, 755, 35, negative 325, those four are all coterminal angles. There are literally an infinite number of coterminal angles for any particular angle because you could just keep adding loops of the circle forever, right? So you're going to have an infinite number of answers. If I had asked you for a positive and negative coterminal angle, if you'd given me these two, that would be totally fine, right? You could give me this one and this one, that's also fine. You could subtract another 360 and give me that one, that's fine too. Okay, so as long as it's a positive and negative coterminal angle, you are all set. It doesn't have to be a particular one. All right, and then this last guy here, so 3 pi over 4. So we need to add a loop of the circle. So think back to radians. We said that radians, 180 degrees is pi, and the full circle is 2 pi. So what I need to do here is instead of adding or subtracting 360, I need to add or subtract 2 pi. Okay, so I'm looking for 2 pi, but you remember how fractions work. That's like 2 pi over 1. I need to make sure I have common denominators. Okay, so I'm going to do 3 pi over 4, and I'm going to add to it this guy, but as a common denominator. So it's got to be a common denominator of 4. So if I multiply this top and bottom by 4, 2 times 4 is 8, and then 1 times 4 is 4. Now I've got common denominators, and that's going to add to 11 pi over 4. So there's a positive coterminal angle. And then for my negative one, I'm going to do the same thing, except I'll subtract. I've already figured out 2 pi with common denominators, so I can just reuse that. So that's going to subtract to negative 5 pi over 4. And there's my positive and negative coterminal angle. So anytime you're doing radians, you just need to make sure you take your 2 pi. It's always going to be 2 pi. And then just convert it so that you have common denominators with whatever your original problem was. All right, so that's all there is with coterminal angles. It's just two angles that end in the same spot, and you find them by adding or subtracting loops of a circle. All right, so now let's talk about converting between degrees and radians. Okay, so converting between degrees and radians, the first thing that you need to make sure that you remember is you need to remember that pi is equal to 180 degrees. Pi radians is 180 degrees. Okay, so if you can remember that, that is going to help you figure these out. Now, I don't know if you remember this, but at some point in your life, you've done unit conversion where you take something like 3 hours and they ask you to convert that to minutes, say. So you say, oh, okay, let me stick this over 1. And if I want to go hours to minutes, then you say, okay, well, I know that there's 60 minutes in 1 hour. And I'd put the 1 hour down here so that they're diagonal units, right? And say, okay, well, 1 hour is the same thing as 60 minutes. So I can make that into a fraction. It's just like multiplying by 1, right? And then when you multiply those, the units cancel, and that's where you get your 180 minutes, right? So if you remember doing that stuff, that's all that we're doing here, okay? But the only difference is that instead of using 60 minutes is the same as 1 hour, we're going to use that 180 degrees is the same thing as pi radians, okay? And that's going to be our converter. All right, so let's take a look at this. So I'm going to start with degrees, and I want to change this to radians. So I'm starting with 240 degrees. All right, and if we think about this, 240 degrees, right, I'd need to multiply that. And I know pi and 180 degrees are the same. I want the degrees to be able to cancel out. So they're on the top here. So the 180 degrees needs to be on the bottom here. And then I can put my pi radians. Okay, and then all I'm going to do is I'm going to multiply straight across. So I'm going to get 240 pi over 180. And then you do need to simplify your fraction. So simplifying that fraction, so 240 over 180. I know the zeros will cancel out, so that's just 24 over 18. And then I'm just looking for a number that'll evenly go into both of those. So I believe 6 does. 6 goes into 24 4 times, and it goes into 18 3 times. So that simplifies to 4/3. So it's going to be 4 pi over 3. Okay, so that's 240 degrees written in radians. So let's do negative 460. So negative 460, if I want to convert this to radians, right, I'm starting with degrees. So I need to make sure that when I multiply, the 180 degrees goes in the bottom. And then my pi will be up here. Multiply straight across, I'm going to get negative 460 pi over 180. And then again, to simplify that, so negative 460 over 180, the zeros will cancel. And then I need a number that evenly goes into both 46 and 18. 2 is the first thing popping out at me, so I'll make that negative 23 over 9. And I think that's it. 3 is the only thing that goes in there, and it doesn't go in 23, so that's my simplified fraction. So negative 23 pi over 9. All right, so that's how you're going to convert from degrees to radians. Now going the other way is almost the same thing. Okay, it's just a tiny bit different. So just like with our unit conversion, right, we make sure that these guys match. Well, now when I'm converting this one, I'm starting with pi over 4. That's already in radians. So when I multiply this, I want to make sure that the pi goes on the bottom. So see how the pi's will end up kind of canceling? And I want my 180 degrees because I want my final units to be in degrees. So then when we multiply these straight across, these guys are going to cancel each other out. And I'm going to be left with 180 over 4, which then again, of course, we're going to simplify. So 4 goes into 180 some number of times. I can't think off the top of my head. 45. So that's going to work out to 45 degrees, right? Because 2 would go into that 90 times, and then 2 again would be 45. Okay. All right. So then last one here. So I'm starting with negative 11 pi over 5. I'm trying to get rid of the radians. So I want to put the radians on the bottom, and I'll put degrees on the top. The pi's are going to cancel each other out, and then I'm going to multiply straight across. So negative 11 times 180. I don't know this one off the top of my head. So 11 times 180, that's going to be negative 1980 over 5. When I divide that by 5, 396 negative. Make sure you don't drop that negative. So that's negative 396 degrees. All right, and that's it. That's how you convert between degrees and radians. So you just got to make sure, right? It's the same fraction. It's a pi and a 180. You just got to make sure that you put the pi in the right spot. Okay, so if I want the degrees to cancel out, then the degrees need to go on the bottom. If I want the pi's to cancel out, the radians, then they have to go on the bottom. Okay, and that's all there is to converting. Now, just as a quick side note, you could also use the fact that 2 pi is equal to 360, and some people prefer to do that. They'll use 2 pi up here and 360 down here, or 360 up here and 2 pi down there. That will totally work. You just will have to simplify your fraction a little bit more. So either way is fine.